In this video, we're going to learn about covalent bonding and naming. In the beginning of this chapter, we discussed how covalent compounds are formed when you have two or more nonmetals sharing electrons to form a covalent bond. Remember that when you have a metalloid combining with a nonmetal, you also form covalent bonding. We can see in the image in the bottom that it is illustrating how when it comes to these combinations of nonmetal and nonmetal or metalloid and nonmetal, sharing of electrons is what makes a covalent bond. And sometimes remember that we can illustrate it with a line. We're going to see later in the semester that covalent bonding is one of the main types of bondings that we're going to see in biological systems. In the image that we have here from figure 3.11, we can see that in biomolecules like DNA, nonmetals like carbon, hydrogen, oxygen, nitrogen, and even phosphorus come together to give life to those biomolecules. Let's now go over how to name binary covalent compounds. When it comes to naming covalent compounds, understand that we need to do first, give the name of the element given first in the formula, meaning the first nonmetal or metalloid. A prefix is going to be utilized only if you have two or more atoms, and you will know that you have two or more atoms for that first element because of its subscript. Then for the second atom, which in this case is always going to be a nonmetal, you're going to give the stem name of the nonmetal followed by the suffix "ide." That second nonmetal will always have a prefix. How do you determine the prefix names? You can see them summarized in table 3.4. And the prefix that you need to be familiar with are going to be from number 1 all the way to number 10. Let's do some practice problems so we can see how we go from chemical formula to name for covalent compounds. As I mentioned, when it comes to prefixes, the first element only gets a prefix when you have a subscript of two or more. The second name always gets a prefix. Let's do some of these examples to see how that comes into play. Let's do letter A. We have PBr3. Since phosphorus in PBr3 has a subscript of 1 and it is omitted, remember, if you have only one atom for the first element, you don't write a prefix. So we're just going to write the word phosphorus. We see that the subscript bromine is 3. So the Greek prefix is tri. And then we're going to use the stem of its name followed by the suffix "ide." So this is bromide. So the name of PBr3 is phosphorus tribromide. Let's move on to letter B. Cl2O. My first nonmetal has a subscript of 2. So I'm going to put the prefix di to symbolize the 2, and then the name of that element, dichlorine. I'm going to put the second word below because of spacing. I only have one oxygen. And then because I only have one, and the second word always gets a prefix, the prefix for one is mono. And then the name for oxygen based on its stem and suffix "ide" is oxide. When it comes to oxide as my second nonmetal in a covalent compound, I have to be careful. Because if my prefix ends in O or A, I need to delete the O or A in the prefix and then make one word. So the correct word to write oxide in the context of this chemical formula is to write the word monoxide as one word. Writing monoxide will be incorrect. Let's go over example C. In example C, we have carbon. Bromine has a subscript of 4. The prefix is called tetra. The name for bromine will be bromide. In letter D, I have hydrogen, which no subscript, so it doesn't get any prefix. The second word is mono. Fluoride, because I only have one fluorine. Next, I have nitrogen, because fluorine has a subscript of 3. This is trifluoride. On letter F, I have CS2. This is carbon disulfide. On letter G, since my phosphorus has a subscript of 2, this is diphosphorus. 5, the subscript, the prefix is penta. And because I have oxygen, is pentaoxide. And as I mentioned, if your prefix that you are combining with oxide ends in O or A, we need to erase the O or A. So in this case, the A in penta goes away, and we make one word. So you don't write that second word as pentaoxide, is pentoxide. Next one, we have a metalloid and a non-metal. So this is silicon. And since we have only one of them, it doesn't get a prefix. And then for the second one, we have a subscript of 2 for the oxygen. So di is the prefix that we use. And then we write the word oxide. Remember that the omission of the last letter in the prefix only applies to prefixes that end in O or A when you combine them with oxide. So di, because it ends in I, we're not going to erase it. And then the last two are going to be phosphorus. Since Cl has a subscript of 3, that it means that it is tri. And the correct word is going to be chloride. And lastly, CO. This is carbon monoxide, because it was similar to the example that we saw here when we had an oxygen with a subscript of 1. Let's now practice going specifically from name to chemical formula. And when it goes from name to chemical formula, all we have to write is the symbol, and then the prefix tells us specifically what is going to be our subscript. So in letter A, we have sulfur dioxide. There's no prefix in sulfur, so we just write S. And then dioxide, that means that I have two oxygens. Next one, silicon tetrachloride. So for this, silicon is Si, chloride, it says that there's tetra, that means 4. Next, iodine trifluoride. Symbol for iodine is I. Fluoride, it says that there's tri, so that means 3. Last one, dinitrogen monoxide. That means that my nitrogen, there's 2 of them because there's the prefix di. And then monoxide means that there's only 1 oxygen. And that's how we go from name to chemical formula for covalent compounds.